Hello everyone, a very good afternoon to y'all. Right, the chemistry paper 1 is upcoming, so we have collected many questions from our followers and we are going to go through them one by one. Okay, first question. Caitlin, do you want to start first?
Sure. Okay, so for this question, we'll be linking it to QA, qualitative analysis. Okay, it's a bit laggy on the screen. Okay, so when we add aqueous ammonia, we get a white and light blue precipitate. So we need to immediately know that when it's a light blue precipitate, there's usually only one cation, which is copper. Okay, then let's continue reading. So light blue precipitate dissolves in excess. Obviously, it's copper again, and then it turns and forms a dark blue solution. And then the white precipitate remains insoluble. So when it's insoluble, we only have two possibilities, which is either aluminium or lead. Because we have the other one, which is zinc, but it's soluble in excess. So we can eliminate this possibility. So now we are left with aluminium and lead. Okay, then let's continue reading the bottom. So now they are adding barium nitrate and nitric acid. And then it says, the white precipitate form was insoluble in dilute nitric acid. So only barium, calcium, and lead is insoluble as a nitrate. So that's why the answer is PbSO4. And it cannot be AlSO4 because that will be soluble. Okay, so now that we have gathered our basic information, let's read through the options and see which one is incorrect. Okay, so solution X is blue in color, definitely correct. Okay, solution X contains more than one cation. Yes, that is correct as well because we have Pb and copper, which is two cations. So we have more than one. Further tests are required to determine the cations present in solution X. In this case, we don't need to have further tests because we can already decide that it's lead, since they gave us this extra experiment to determine that the salt form is insoluble. If this step was not included, then yes, we need to have further tests to determine whether it's aluminium or lead. Then upon adding excess, C is correct as well. So now let's move on to D. So upon adding excess sodium hydroxide to X, only a light blue precipitate is observed. So excess NaOH, light blue precipitate is observed. Yes, because copper 2 plus ions, they are insoluble in excess NaOH. And for your white precipitate, right, it's actually soluble in excess, and then it will give you a colorless solution. Okay, so that's why your answer is D. Okay, this can sometimes be a bit controversial because when Yichai and I were discussing, right, he thought that D was wrong because the question only stated only. So usually that's not the case because you can also say that the precipitate dissolved in excess. Yeah, like what Yichang is highlighting right now. So but we always look for the best possible answer. So therefore the best possible answer here is C. But there's actually more than one way to interpret option D. Yeah.
Exactly, choose the best answer.
Always choose the
Okay,
best possible answer.
indeed. Okay, shall we
Okay.
move on to the next question?
Yep, let's do it.
Okay,
Okay,
I think I
do you
will.
want to take this?
Sure.
All right.
Okay, so the graph shows the variation of physical property with proton number for the elements from sodium to chlorine in the periodic table. So if we take a look at the periodic table, we can observe that all of these elements are falling on period 3. Therefore, option A, atomic radius. So does it go up until silicon and then go down? The answer is no. Actual fact is that the elements across a period has the same atomic radius. So the graph will go like one straight line. Okay, secondly, electrical conductivity. As we know, as giant metallic bonds, there is free moving electrons in the sea of delocalized electrons. Therefore, metal conduct electricity. Okay, so these three will conduct. And for the rest of them, there are covalent bonds which lack the presence of free moving charged particles. So therefore, the electrical conductivity decreases across the period. C, melting point. Can this be correct? When we talk about melting point, we are referring to the forces of attraction, how strong they are. So for a giant metallic structure, the melting point is quite high. However, for a giant covalent bond, it is even higher because large amount of energy is needed to break numerous covalent bonds that hold the particles together, hold the giant covalent molecules. Is it correct to say that? Together. And for simple covalent molecules, simple molecular structure, little amount of energy is needed to overcome the weak van der Waals forces of attraction between the molecules, and therefore the melting point is low. In conclusion, this will be the line for melting point. Last but not least, for density. In the chapter of periodic table, we have learned that metals, they have high density. Additional information for group 1 metals, which are known as alkali metals, the density actually increases down the group. So therefore, the density should decrease across a period due to the property of the elements. Hence, the answer is C. Okay, moving on to the next question. This is a more concept question. So we have a lot of information in this case, hence we need to do a lot of labeling. A solution contains 12.60 G per dm cube of the acid. So this is the acid and this is the concentration. Take note that this is in gram per dm cube. 25 cm of this solution of the acid. Therefore, we label 25 cm cube. Reacted with an equal volume of 0.1 mole per dm cube of sodium hydroxide. So this concentration is 0.1 number of mole per dm cube, as shown in the equation. Okay, it's an equal volume. Hence, it suggests that the sodium hydroxide also has a volume of 25.0 cm cube. Now, we're going to find element Z. To be able to identify element Z, we are trying to look for the element which has the same AR, relative atomic mass, as Z. From there, we need to have the relative molecular mass, the MR of the acid. And how do we have the relative molecular mass of the acid? MR times the number of mole equals to the mass. Okay, so we are going to find out the mass. However, there is also another way to find out its MR. Let's try how to find the MR of this. Firstly, find the number of mole for this. So we ignore this first, okay, because all of them are in cm, hence the number of mole equals to concentration times volume, which is 2.5 number of mole. By mole ratio, no is to unknown, so the number of mole for acid is also 2.5 mole. Then we know the volume. Hence, concentration equals to the number of mole divided by volume, which is 0.1 number of mole per dm cube. Take note that we have two concentrations here. One is in gram per dm cube and the other one is in mole per dm cube. What's the relationship between two of these? Maybe I can ask Caitlin. What do you think is the relationship between two of these?
So we know that mass is equals to mole times your MR. So we can take mass divided by the number of moles to find the MR of H3ZO3.
Exactly. Wonderful. So the MR of this would be 2126. Then to find the AR of element Z, 126 minus 3 times 16. We have 75, and if we are to check, that's right. So the answer is A. That's about this question.
Yeah. Okay, so I think I'll be going through the next question. So the next question is about energy changes. So we'll think about enthalpy change. We'll also think about, endothermic and exothermic reactions. So over here, we can see that the enthalpy change is a positive value. So every time when we come across a positive value, it's always endothermic. So what does endothermic mean? Endothermic means that more energy is taken in to break the bonds. Okay, more energy is taken in to break the bonds than energy given out to break your bonds. So more energy given out to break your bonds is an exothermic reaction. So here we have an endothermic reaction, and we know that 0.2 moles of ammonium chloride dissolves in 50 cm cube of water. So option 1, they gave us that it told us that the concentration is 4 moles. So we just press our calculator, 0.2 times 50 over 1000, and we realize that yes, the first one is correct. Next, option 2, the energy level of NH4Cl increases. Okay, let's draw a simple graph at the side to depict this reaction. So usually for an endothermic reaction, your graph will look something like that because energy has been taken in. So this is your activation energy, EA, and this is your enthalpy change. Okay, yeah, okay. So yes, the energy level of your reactants increased because you guys can see the starting and the ending energy level actually increased. So therefore, option 2 is correct as well. Okay, so let's move on to option 3. The heat liberated is 3.0 kilojoules. Liberated. Actually, a better word should have been used because liberated is mostly used for an exothermic reaction, but we are focusing on an endothermic reaction. So it should have been absorbed or taken in instead of liberated. So 3 is wrong. Okay, next one. The temperature of the solution falls. Yes. So for all endothermic reactions, your temperature of solution will fall. In an exothermic reaction, your temperature will increase. So that's why the correct answer is B instead of C. Okay? So this is for question 21. And now let's do the last question we have for today. Okay, so beryllium hydroxide is an amphoteric white solid. So amphoteric here is the keyword of our question. Which reagent can be used to distinguish between beryllium hydroxide and solid calcium hydroxide? So this is not aqueous, it's solid calcium hydroxide. Okay, so let's say if we add acid into both solutions. So if we add acid into both hydroxides will liberate hydrogen gas sorry, they will liberate water. They will give us a salt plus water. So in this sense, we can't really differentiate between the two. So that's why an acid here would be wrong. Okay, so this one is wrong, not H2 gas. It will be water. Okay, but then when we add an alkali, we realize that only beryllium hydroxide will react, because an amphoteric solid will react with both acids and alkalis, whereas on the other hand, calcium hydroxide does not react with another alkali. So that's why when you add an alkali, right, you will immediately know the difference. Your beryllium hydroxide will keep reacting, while calcium hydroxide will not react. So that's why the answer here is D. Yeah. So
That's very clear.
that's the end.
Okay, so towards the end of the video, we hope that all of us will do our best for the Chem paper 1. Yeah, all the best.
All the best, guys.
Bye bye.
Bye.